All right, if we take this circle right here, and we want to find the trig ratios at any given angle. Let's take a look at this 30-degree angle. Okay, when you look at this angle right here, and you, again, all of these, when we're finding the angles, let's assume that this circle has a radius of 1. Okay, so if all we know is this measure is 1, can we find what the coordinates are for this point? How would we do that? Okay, so if we make our 90-degree angle here, so we've created this right triangle. And how can we find what this length is here? Okay, so we've got one suggestion using trig ratio, so let's take a look at that. So we have an angle. We want to find this opposite side, and we know, let's call this, I'll call this A. So we have an angle, we have an unknown side A that's opposite, and we have a hypotenuse that we know. So which trig ratio is going to relate these? Sine. So what we could do is take the sine of 30 degrees, set that equal to A over 1. Okay. And so what is the, in this value A is which coordinate of this point? Is it the x coordinate or the y coordinate? It's the y coordinate, right? So when I look at this, if I know that here I just need to multiply by 1, right? So A is equal to the sine of 30. So this measure right here is the sine of 30 degrees, correct? And what about this x coordinate, or this length across here, which I'll call it B? Okay, how would we set up a relationship to find, or using this angle of 30 degrees, this adjacent side and this hypotenuse? Okay. So, right, so adjacent hypotenuse, you have the cosine. So you could set up the ratio cosine of 30 is equal to adjacent B over 1. And so what is our B value is the length. This length right here is the value of cosine of 30. So when we look at this, we have cosine of 30. So what do you think is going to happen if I take another angle? Let's call this angle 60 degrees. Okay, so at 60 degrees, we still have a radius of 1. And let's say we want to find the x and the y coordinate here. Okay, so in looking at this, let's find the x coordinate. So here, this measure is going to help us find the x coordinate. Okay, so I'm just going to call it x1. Okay, so which trig ratio relates? Our angle, cosine. So we have the cosine of 60 degrees is equal to x sub 1 over 1, which means that x sub 1 is just cosine of 60. And how would we find this? I'll call it y sub 1. This y value is opposite over hypotenuse, so it's going to be which ratio? Sine of 60 equals y the 1 over 1, which means our y the 1 is sine of 60. Do you see a pattern already in just these two? So what do you think is going to happen here? The x and the y coordinates along this circle. They're always going to coincide with the what? Yeah, the cosine of the angle is your x coordinate. The sine of the angle is your y coordinate. Okay, this is called the unit circle. And this relationship, again, the unit circle is one in which the radius is 1 and the origin is the center. Okay, and it's going to be true for every angle around this whole circle. Okay, so what that means is if we take let's say we take this unit circle here. Okay, and remember, in the unit circle, if you recall the angles that you need to be aware of, it is 30 degrees, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. And then we also have the multiples of 45. So 45, 90, 135, 180, 225, 270, 315, back to 360. Okay, so these are all the angles of your unit circle. Okay, so again, this is an example of a unit circle where the radius is 1. And so what we found was the coordinates at these given points, the x and the y coordinate, are just the cosine and sine values. So use your calculator.
What did you say sine was?
The cosine of 30 degrees. Square root of 3 over 2. And what would the sine of 30 degrees be? 1/2. Okay, so this angle right here, 30 degrees, has a cosine of root 3 over 2 and a sine of 1/2. Okay, now, the triangle that's used for this, and actually every single one of these calculations is based solely on a either 30, 60, 90 or a 45, 45, 90 triangle, which are ones that you guys should have some specific rules for. In a 30, 60, 90 triangle, the way that the sides relate to each other is the side opposite. The 30 degrees is some value x. The hypotenuse is twice that. And the side opposite, 60 degrees, is x root 3. So it should make perfect sense that this cosine, which is the adjacent over hypotenuse. So when you look at this 30 degree angles, the adjacent side is x root 3. The hypotenuse is 2x, so x root 3 over 2x is actually equal to root 3 over 2. What is the sine? The sine is opposite over hypotenuse, so x over 2x. The x's cancel, leaving an answer of 1/2. Okay, so what do you think is going to happen right here at 60 degrees? It's the same triangle, only now when you're looking at the cosine, the adjacent side is x and the hypotenuse is 2x. So what's the cosine of 60 degrees going to be? X over 2x, which is 1 over 2. And then the opposite, or in this case the sine is opposite over hypotenuse. So from 60 degrees, the opposite is x root 3 over 2x. That's equal to root 3 over 2. Okay. Right, so they're just opposites of each other, right? They're just flipped. And that should make sense because this triangle right here, if we take this triangle